Hello everyone, today we are going to start A-level paper code 9709, variant 2, February-March 2023, and let's start. This is your P1 paper. Okay, so I have already solved this paper. I'll just make you understand this in this video. Okay, a line has an equation this and a curve has equation this where k is a constant. Show that the line and curve meet for all values of k. Okay, we know that whenever there is the line and the curve are going to meet, there must be some point of intersection. Okay, and to find out that, we'll equate them. Okay, and secondly, after that we are going to find the discriminant, that is b square minus 4ac. They haven't mentioned that how many points of intersection there are. If they have had mentioned that there is one point of intersection, then we'll put this discriminant b square minus 4ac equals to 0. Or in the other two cases, either greater than 0 or smaller than 0. But here they haven't mentioned, so we'll just find out the b square minus 4ac. But before that, let's begin with the equating these two equations and making it a quadratic in x. Okay, so 3x minus 2k, the equation of line, is equals to the equation of curve, that is x square minus kx plus 2. So now arranging this, making this side shifted to this side because we need positive x square. It is a preferable thing. So x square minus kx minus 3x plus 2 and plus 2k. So this is what we get. Next, we are going to just arrange the x values together and the constant values together. Okay, so x square minus k plus 3 in the brackets x plus 2 into 1 plus k equals to 0. Next, now when we make a quadratic equation in x, then we are going to find the discriminant b square minus 4ac. You know, here a is 1, b is this minus k plus 3. Okay, we are taking it with the sign. Why? Because the general form is ax square plus bx plus c. So b is going to be minus k plus 3 inside the brackets, and c would be 2 into 1 plus k. So substituting these values in your discriminant, let's see. This will give you b square minus 4ac. We'll expand this. Obviously minus 1 whole square would be positive 1, so minus is vanished over here. Then k square plus 6k plus 9 minus of 8 of 1 plus k. Then just arrange this all a bit, so you will get this form, k square minus 2k plus 1. So see, we can write it in the square bracket form because we know this formula, a minus b whole square is equals to a square, where here a is k, plus b square, where 1 is b, and minus sign suggests that this is minus 2ab, so minus 2 times k into 1. So this is going to give you minus 2k. So this suggests that this is the bracket form of k minus 1 whole square. Okay, the expanded form of k minus 1 whole square. Okay, so we have to give the reason. In the question they have asked you, show that the line and the curve meet for all values of k. So see, k minus 1 whole square is greater than or equals to 0, so it meets for all values of k. How can we say that? See, whenever they have given you this one, okay, we know that if b square minus 4ac is greater than 0 or equals to 0, that means that they have a point of intersection. Okay, either 1 or 2, and they have a real root. So this is the reason that we are not specifying it with just one condition, that it is greater than 0 or smaller or equals to 0, because it is not given over here, but they are just asking the point of that they are meeting for all values of k. So this will suggest us that k minus 1 whole square is greater than or equal to 0, so it meets for all values of k. I hope you will understand this. Now let's move on to the next part. This is your next question. Okay, a function f is defined by f of x is equals to x square minus 2x plus 5 for x is a member, x is a real number. Okay, a sequence of transformation is applied in the following order of the graph to the graph of f y is equals to f of x to give you the graph of y is equals to g of x. So stretch parallel to the x-axis with scale factor 1 by 2, then reflection in the y-axis, and then stretch parallel to the y-axis with a scale factor 3. Okay, there is a sequence of transformations. So we have to find g of x, giving your answer in the form of ax square plus bx plus c, where a, b and c are constants. Okay, fair enough. Let's first, what are we going to do first? This is your equation, write it down, x square minus 2x plus 5. This is f of x. Then they are asking you to stretch parallel to the x-axis with a scale factor 1 by 2. Okay, whenever we are giving a stretch parallel to x-axis with a scale factor 1 by 2, that means that your function inside is being multiplied by with its reciprocal. Okay, that is 2 over here. So inside we will multiply all the x with the 2. Okay, so this is why we have done 2x whole square minus 2 into 2x plus 5. Okay, let's simplify this all. You will get 4x square minus 4x plus 5. Next is reflection in y-axis. What does that mean? That means that in y-axis you are going to get your reflection. For example, your curve is here, then it is going to be reflected in the y-axis. So obviously you will be having a minus sign inside the function. Okay, when it is a reflection in y-axis, you will be multiplying it inside with a minus. Okay, so let's do this. 4 into minus x square minus 4 times into minus x plus 5. Okay, so we'll substitute everywhere where there was x, so we'll substitute it with minus x. Okay, here we are writing minus 2x because already we have applied the 2x, like 2 times of x, and now we are multiplying it with minus. So I am directly applying here with just minus because already 2 is being multiplied. Next, we'll arrange this a bit and we'll be getting the simplified form 4x square plus 4x plus 5. Now stretch parallel to the y-axis with a scale factor 3. See, first it was the stretch parallel to the x-axis, so we multiplied inside with the function with the 2, the reciprocal. Now if it is stretched parallel to y-axis with the scale factor 3, then you are going to multiply it outside the function with the 3. So you are going to multiply the whole okay, so you are going to multiply with 3 the whole function and you will be getting 12x square plus 12x plus 15. So this is the sequence of transformations. Okay, it is better to do it like this stepwise. Okay, obviously this is a 4-mark question, so you have to do it this way, so everything needs to be very clear. Okay, done. Let's move on to the next question. A curve has an equation y is equals to 1 over 60 3x plus 1 whole square and a point is moving along the curve. Find the x coordinate of the point in the curve at which the x and y coordinates are increasing at the same rate. Okay, now this is the question of your rate. So first if we have to find this rate, so we obviously need to find dy by dx. So first take your equation of curve y is equals to 1 over 60, 3x plus 1 whole square, and derive it. Okay, 1 over 60 is constant, it will stay as it is. This will give you derivation nx n minus 1. So see x over here, or your main bracket is 3x plus 1. Okay, so first you'll solve the power. 2 bracket inside 3x plus 1, n minus 1 is 2 minus 1. This will give you 1, and multiplied by the derivative of the bracket, and the derivative of the bracket is like 3x plus 1, derivative is going to be 3. Clear? Now next thing is you'll simplify it. You'll get 1 over 10 3x plus 1. Now if they are telling you that this dy by dx is moving at the x coordinate of the point on the curve, at which x and y coordinates are increasing at the same rate. So this is going to give you dy by dx equals to 1. How? Let's find it out. See, for your rate question, you know that dy by dx is equals to dy by dt into dt over dx. Okay, rate means it is changing with time. So then if you take its reciprocal, like if you write it as a division, the main important point is this, that they say that y and x coordinates are increasing at same rate. Okay, so that same rate means that dy by dx dt rate is equals to dx over dt. So that means if they both are going to be equal and they both are divided, so we can substitute dx by dt equals to dy over dt. So this whole will give you equals to 1. This is how we get it. Okay, or simply you can infer this if you are fluent with this all working. Okay, so this gives you dy by dx equals to 1 because x and y are increasing at same rate. So this is going to give you 1 equals to 1 over 10 into 3x plus 1. 10 will be multiplied on the this side, and you'll be getting the value of x, that is x equals to 3. Okay, this is what they were asking in the first place, like find the x coordinate of the point on the curve at which the x and y coordinates are increasing at the same rate. I hope you get this question. Okay, now let's move on to the next. Question 4. Question 4 says that the circumference round the trunk of a large tree is measured and found to be (5 meters). After 1 year, the circumference is measured again and found to be 5.02 meters. Given that the circumference at yearly intervals form an arithmetic progression. So this is an important point in this question, that they have given you that this is a question of AP, arithmetic progression. Okay, so underline that and apply all the formulas and working according to it. Find the circumference 20 years after the first measurement. Okay, so first let's find out all the data that we have. They have given you the first term, A or A1, that is 5 meters, A2. Okay, after 1 year it is going to be 5.02 meters. And let's now find out the common difference that is very much needed in arithmetic progression. Difference is going to be the difference between any two consecutive terms. So 5.02 minus 5. So this is going to give you 0.02. Now apply your nth term formula. This is your nth term formula, a1 plus n minus 1t. There is a little trick in this, that if they are telling you that find the circumference 20 years after the first measurement, so that doesn't mean A20. They are telling you after first measurement the A1 is started, and that means A1 plus 20 terms sum plus A1, because 20 years are being started to be counted after 1 year, okay, after first measurement. So that means that you have to find the A21. That is the tricky part in this. Okay, so read very closely whatever is written in your question, and there will be no errors then. Okay, let's now start doing this. Okay, so A21 is going to be A1, that is 5, plus n minus 1, that is 21 minus 1. Here is 21 minus 1 that I wrote as 20. Okay, so solving this all will give you A21 equals to 5.4. Let's move on to part B. Now, the same question is converted into geometric progression. See this? Given instead that the circumferences at yearly intervals form a geometric progression, find the circumference 20 years after the first measurement. So now we are applying the formulas and the workings of geometric progression. So you know, you have to now find the A21 for a GP. So write down all the data again. A1 was 5, A2 was 5.02. Now instead of common difference, we'll find the common ratio. So that is 5.02. Second term divided by the first term. This will give you 1.004. A21 is going to be A into R n minus 1. So solving this all will give you this. Okay. That's it. Okay, so let's start with question 5. Points A and B lie on a circle with center, we call it as C. The line AB has equation this. Find the coordinates of B. Okay, let's understand this first all. We have a point A and B that lies on some circle. That's in the questions like these of circle, it is better to just sketch a diagram that is like a little bit close to actual one. See, A point is 7 and 12, so 7 is somewhere here and 12 is somewhere here. Then B we don't know obviously, so we'll just think of it anywhere. And point C is -2, 5. So -2 is this on x-axis and 5 is on y-axis, so somewhere here. Okay, so we'll see, and now we'll draw the circle according to it. First we mark the points and then we will draw a circle. Okay, now let's see, find the coordinates of B. So we know the coordinates of A, we know the line, equation of line. So what are we supposed to do? How can we find the B? See, if we know one point on a circle, if we find the equation of the circle, we can also find the other point on the circle. Yes, when we find the point of intersection of the line and the circle. So this is what we are going to do in this. So line AB has an equation this, center C is -2, 5. Can we find the radius of the circle by We know one point, and do we know another point? Yes, we know a point. So we'll find the radius r from this AC. Okay, so by using the distance formula, A point has coordinates 7, 12, and C has -2, 5. So use them. 5 minus 12 plus whole square plus -2 minus 7 whole square. Solving this all will give you the radius. Okay, now from this radius and center of the circle, we'll write the equation of the circle. So the equation of the circle is going to be x minus a square plus y minus b square, and we know that a and b are the coordinates of center, -2 and 5. Okay, so it becomes x plus 2 whole square plus y minus 5 whole square is equals to r square. Okay, and we know that r is equals to 130 under the root, so r square is equals to 130. So writing this all, and then we want to find the points of intersection, so we can substitute this y in place of this y. So we substitute this, we will find the point of intersection. So this will give you -2x plus 26. Yes. Okay, now solve this all. Open these two brackets, x squared plus 4 plus 4x, this one, and then -2x whole square plus 21 whole square, or you can consider it as 21 minus 2x whole square a minus b whole square. So a square 4x square plus b square 21 square minus 2ab. So this is going to be this, and minus 31. Simplifying this all will give you this. And further, from this quadratic equation, what we will do, we'll simplify it. Obviously we can divide this whole by 5, so we are doing that, and then we'll get a simplified version like this. Now we can factorize it. So minus 16x. See, we always do this. We need to find, while breaking the middle term, we need to find two numbers that when multiplied give you the product of these outer two terms. That is going to be 63, or you can do it like 63x squared. I do it this way, and adding or subtracting this of this two factors or the two terms will give you minus 16x. So by adding you should get minus 16x. Okay, so these are our two numbers which when multiplied, minus 7 and minus 9 will give you plus 63x squared, minus 7x and minus 9x, and when added will give you minus 16x. So this is all. Then simplify this, you'll get x minus 7 into x minus 9 equals to 0. So this implies that x is either equals to 7 or 9. Let's now see how to decide whether we are going to use the 7 or 9. So see, obviously we'll see from our figure as well that which point will satisfy it. X equals to 7. Yeah, why we are not taking x equals to 7? Because obviously we are getting 2 points of intersection by solving the equation of line and equation of circle. One will be the point A that we already know is 7 and 12. So we are not, sorry, not minus 7, it was 7 and 12. So this is already we have. So we'll not work for this, we'll find out the other one, and we get the x coordinate for the other one as 9. So then substituting this equation, this value of x and value of y, we'll be getting the value of xy coordinate, and then this is your point B coordinates, and this is how we found it. I hope you got the idea how we are solving this whole. Okay, now let's move on to the next. Okay, so question 6 is about the expansions. So we know that we have a few formulas for the expansion, so we are going to apply that. Let's read the question. In the expansion of x over a plus a over x square whole power 7, it is given that the coefficient of x power 4 over the coefficient of x is equals to 3. So this is the relation that they have given you. We'll find the coefficient of x4, we'll find the coefficient of x in the given term, and we'll equate it, we'll divide them and put it equals to 3. Find the possible values of the constant a, and we are going to find the values of a. Okay, simple. So we know for the term, required term, we use this formula: tr plus 1 is equals to ncr a n minus r b power r. So what is n over here? N is 7, a is x over a, and b is a over x square. So first write it down. Okay, then in the next step, distribute your powers to the numerator and the denominator for both x over a and a over x square. Then you have to separate the x terms and the a terms. Okay, so x power will become 7 minus r minus 2r, and a power will become 7 minus r and r minus of 7 minus r. Okay, so we'll do this and then simplify this whole. We'll get the required. So let's now, we are going to find the x power 4 coefficient and x power 1. So we are going to equate this x power equals to x4 first and find out the value of r. This is what we need. Actually, we in all this formula, what is not known is r. Otherwise we could have found the required term. So for that, we are going to first put it equals to x power 4 and then equals to x power 1 to get our required r, that which term we actually need, in which we will be having x power 4 coefficient and the other one is x power 1 coefficient. Okay, so we get r equals to 1 and r equals to 2. So we'll substitute this in the given this equation that we found, and we'll get the coefficients of both. See, for the first one, 7c1, x power 7 minus 3 into 1 and a power 2 into 1 minus 7, and solving this will give you 7c1 is 7, x power 4 and a power minus 5. So this will give you 7 over a 5 x4. The second, by putting x equals to 2, r equals to 2, we will be getting this 21 over a cube into x. Now, next thing is, we are going to use your given this initial relation that they say that coefficient of x4 over coefficient of x is equals to 3. So see, coefficient of x4 is this and coefficient of x is this. So divide them, they will be equals to 3. So 1 over a square over 3 is equals to 3. So that means that 1 over a square equals to 9, and a square is equals to 1 over 9. So this implies that a is going to be equal to plus minus of 1 over 3. Okay, so this is what they have asked. Find the possible values of the constant a. So we are finding the multiple values of a because they have asked us to find all the possible values. So this is the whole working. Okay, so question 7 now. By obtaining a quadratic equation in cos theta, solve the equation. So see, tan theta into sin theta is equals to 1. So first we can do is to substitute tan theta equals to sin theta over cos theta. This is what we have done. Then this cos theta will be that is in the denominator can be multiplied on the right hand side. So this form of equation is obtained. Now we have to make it quadratic to cos, so we will use this version of our equation sin square theta plus cos square theta equals to 1, that says that sin square theta is equals to 1 minus cos square theta. So we'll substitute that, arrange this, and we'll get this cos square theta plus cos theta minus 1. This is quadratic in cos theta now. There are two ways to move to solve this further. Either you can do it directly, apply the quadratic formula like I have done, or you can substitute cos theta equals to x. That sounds very easy to most of the students, so you can do it that way. I have done it directly and find the cos theta. You can first find x by putting cos theta equals to x, and then you can substitute it back. Okay, so see, a is 1, b is 1, and c is minus 1. So we'll substitute that in our formula, show them this all substitution, and then we'll get the cos theta equals to minus 1 plus minus and root 5 over 2. Now we have to find the angle theta. So for that we have the two values for cos theta. Solving this will give us no solution, okay, and this part will give us this value. Okay, so this is our in the decimal. So first we'll find the alpha. We know that alpha is cos inverse of this quantity, and this is your basic angle. Now we have to find, we'll draw the grid. We have if in the start you remember, we have the range of from 0 to 360. So the angle is available in the all four quadrants. We see that this is a positive numbers, this one. Okay, so we can use the cos quadrants. First quadrant is cos quadrant, and fourth, as you know, A, S, T and C. So in first quadrant it would be 51.82 degrees, and in the fourth quadrant it is going to be 360 minus 51.82 degrees. So this will give you these two angles. Okay, fair enough. So this is your whole working. Now let's move on to the next question. Actually the same P part of the same question. Now they say that there is an identity tan theta over sin theta minus sin theta over tan theta, that is equivalent to or identity tan theta sin theta. Okay, so we have to show that. So we are using the left hand side, and if we have to transform this into tan theta, so we are tan theta sin theta. So first what we can do is change all the tan to sin over cos. So this is what we have done. Then simplify this a bit, sin theta over cos theta sin theta, and minus sin theta. This is what is dividing in the denominator. When we multiply, it will become cos theta over sin theta. Okay, so this will become sin theta cos theta over sin theta. Now in the next step, we'll simplify this a bit. Sin theta will be cancelled in both the terms. So it will become 1 over cos theta minus cos theta. So see how now you can change this into tan theta sin theta. So first take the LCM. Cos theta will be in the denominator and you will get this form, and 1 minus cos square theta you know is sin square theta. Then sin theta over cos theta will become tan theta, and the sin theta will stay as it is. So here we prove this identity like this. Okay, so in proving the identity you just need to find the right side and start solving it, and find you are going to get the other side in the process. Okay, yeah, now let's move on to question 8. Question 8 says the diagram shows a triangle ABC in which angle B is right angle. Okay, let me change the marker so I can just show you. This is your ABC. Okay, and B is a right angle, so this is it. The length of AB is 8 centimeter. This hole is 8 centimeter. As shown in the figure, this part is still here is 5 and this part is 3 centimeter, like this is given. Next thing is and the length of BC is 4 centimeter. This length is 4 centimeter. This is also given. The point D on AB is such that AD is 5 centimeter. D is such that AD is 5 centimeter. Okay, it is also shown in the figure. The sector DAC is part of a circle with center D. Okay, now we are talking about DAC sector. This is DA and C. This is your sector. Okay, with the center D, and obviously then this part AD and DC are going to be their radius. Okay, so ADC I have shown this over here with center D and this radius as 5. You can see from both sides. Okay, find the perimeter of the shaded region. Now find the perimeter of the shaded region. This is your shaded region, so we have to find the perimeter. That means that you need to find this AC arc length and this AC line. Okay, so let's start this. First is you need to find this length AC. Okay, and we cannot directly find this AC. Can we find this AC directly? If you do it as AB square plus BC square, can you apply the Pythagoras theorem? So this will become 8 square plus 4 square, so be 64 plus 16 is going to be 80. So AC is going to be under the root 80. Okay, so let's see. Yeah, this is how we found it. Okay, we didn't need it to do this. I thought we have done it some other way, but we have done it the same way. So applying this Pythagoras theorem, secondly we have to find the arc length AC, and for that we need this angle, the angle subtended by this sector at the center. Okay, so for that we can't directly find this angle, we need to find this alpha. Okay, because we can find this easily, and then we'll do a 180 minus alpha or pi minus alpha. So for that you can use the trigonometric ratio. So sine alpha is going to give you 4/5. 5 is what we know from that these both are the radius of the radii of the same sector. So 4/5 sine inverse of 4/5 will give you 0.9272. So this is your alpha, and your theta is going to be equals to pi minus alpha. So this is your angle. If we know the angle, we can easily find the arc length, as arc length is equals to r theta. So r is 5 and theta is pi minus 0.9272. So this will give you this value. Now the perimeter is easy, as we have written the relation in the start. Perimeter is going to be equals to arc length AC plus length AC. So adding these both will give you this 20.0161. Okay, it is better to write your answer to up to 4 decimal places. Like after the decimal, you need to write the maximum number of digits, so you don't need to round it off by yourself. Your examiner will do it. So this is your whole working. Check this out. We have part B of the same question. They are saying that find the area of the shaded region. For the area of the shaded region, this is your area, this is your shaded region. For that, what we need to do is to find the area of the sector, this, and then subtract this area of this part, this triangle, and we'll get the area of the shaded region. For that, we need to find the area of this triangle. This is D, this is A, and this is C. Okay, you know that we know the two sides and the included angle, so we can apply the formula of sine angle identity that says that area of triangle ADC is equals to AB times sine of the included angle, that is sine C or whatever the names are. So we'll do that. Area of triangle ADC is equals to half. This was our triangle. This was theta. So this was 5, this was 5, this was A, D and C. Okay, so we are substituting 5 and 5 and the included angle, and we get this area. Now we have to find the area of the sector. For the area of sector, we know half r square theta. R we know is 5 and theta is already we found it 2.2143. So we got the area of the sector, we got the area of the triangle. So now we can simply do this as we can subtract them, because we knew that area of this shaded region was area of sector minus area of the triangle. So subtracting these both, 27.6787 minus 9.999. Okay, and we'll get this. So do not round it off during the process of doing it, and you will get the most accurate answer or close to accurate. Okay, so that's it. Okay, so question 9 says the function is defined by minus 3x square plus 2 for x is smaller than or equal to minus 1. This is the given domain. State the range of f. Okay, to find the range of function, what we can do is simply substitute a few values of the domain, like the values of x, to find the value of y, the range. Okay, so f of minus 1 will be equals to minus 1, and f of minus 2, by substituting another value, will get minus 10. So we can roughly sketch this also on a grid. See, if it is x is minus 1, then y is also minus 1, y or f of x. And if x was if x was minus 1, so the y was minus 1, and if the x was minus 2 this point, then y was somewhere here minus 10. So we can roughly sketch this to also to tell the range, and this will give you the values of y or f of x. So this is how you can infer your range, that it is going to be less than or equal to minus 1. Now find an expression for f inverse of x, and this is pretty easy. We just have to follow the simple steps. For f inverse of x, first you will write the y is equals to f of x, then makes x your subject, so take out x as you took it out over here, and then put it equals to f inverse of y, and then change your y to x. I hope it doesn't sound so difficult. Simply make the x subject, then put x equals to f inverse of y. Obviously from this you can also see this x is equals to f inverse of y, and then you will just change the y into x, and you will get your expression for f inverse of y. Okay, that's it. You can check this whole working of question 9. There is also a part C, so let's do that. The function g is defined by this: for x is smaller than or equal to minus 1, solve the equation. Okay, if you have been given this equation, if you do it like simply by putting all the values all together, then it would be difficult. So what I'm doing is, I am first finding this fg of x separately, g of fx separately, and then substituting in the given whole equation. So minus 3 times, we know that the f of x was minus 3x squared plus 2, so we'll substitute x value, that is going to be minus x squared plus minus 1 whole square plus 2, and so solve this all. A plus b, you can either take minus 1 common and then solve it, or you can just simply treat minus x squared as a and minus 1 as b, and then solve it by expanding it by using the formula. Okay, so you'll get this expression, and by solving out this side you'll get this simplification and this expression. So after solving this both sides, what we'll do, we'll put this in your required this form: this minus this plus 8 is equals to 0. So first write this up as written in the first step, and then simplify it. Okay, minus sign will transform all the minus to change all the signs. So this is how it is done, and then join the like terms: minus 3x squared plus 9 x4 plus 9x4. So this will solve separately, then this one and this one will be solved, and the constant term will be treated separately. So this whole will give you this required form of the equation. Okay, now it is quadratic in x squared. See, I have shown two methods of doing it. You can do it by using quadratic formula or by breaking the middle term. So it is always preferred in P1 to use the breaking of the middle term. You will get the answers by this working as well, but it is better always in P1 to do your breaking the middle term. So do it this way: x4 minus 3x squared plus 2, that means by multiplying you should get 2x squared, and by adding or subtracting you should get minus 3. Okay, so this will give you minus 2 and minus 1, I guess. Yes, this is what we have: minus 2x squared and minus x square. This is why I always prefer multiplying these all, involving your variables with their powers as well. So by multiplying you should get 2x4, and by adding you should get 3x square. So these are the two terms, minus 2x square and minus x square will give you the required result. Okay, so this is it, and then simplify, take common x square, you'll get these two terms, two factors, and then put them equals to 0, you'll get this. Okay, first you'll get x is equals to plus minus 1 and x equals to plus minus under root 2. You'll reject this under root 2 and 1. Why? Looking at your required domain, okay, so x is smaller than or equal to minus 1, so we are rejecting these two terms, and now we will be left with x equals to minus 1 and minus under root 2. So this is your whole working of part C of question 9. Okay, now question 10. At the point on a curve, the gradient of the curve is minus 3 by 2. It's given that the gradient of dy by dx is equals to x power minus 1 by 2 plus k, where k is a constant. Show that k is equals to minus 2. Okay, they have already given you the value of k, but you have to prove it, so you have to show all the workings correctly. See, they have given you that the gradient of dy by dx is equals to minus 3 by 2. So first you are going to equate this, and also we are equating the value of x coordinate. Why? Because at this point the gradient is equals to minus 3 by 2. So putting 4 in place of x and writing this x power minus 1 by 2 plus k equals to minus 3 by 2. Then simplify this. 4 power minus 1 by 2 will give you 1 over 4 power 1 by 2. Then taking out this k value from it, 4 power 1 by 2 means 4 under root 4, and this is equals to 2, and then it will give you minus 4 by 2 and minus 2. This is it. Now part B, find the equation of the curve. If you have the dy by dx and you know the value of the k as well, okay, now you have to find the dy by dx. So you have to find the y, equation of the curve. So you'll integrate this. Integrating will give you this x power n will give you x power n plus 1 over n plus 1. So here n is minus 1 by 2 plus 1, minus 1 by 2 plus 1 over the denominator, minus 2 of x obviously, and plus the constant of integration. Next is you'll simplify this a bit. This will give you this form. Then to find the constant of integration, you'll substitute the point 4 minus 1 that was given initially, and this will give you the value of c equals to 3. Then the equation of the curve will be this. Just look at this whole working. Okay, that's it. Now part C, find the coordinates of the stationary point. Okay, that's it. It is very much familiar. We have many questions like these in our past papers. So coordinates of the stationary point, for find the coordinates of stationary point, we know that dy by dx is equals to 0 for stationary point, so we'll put this equals to 0. We'll find the value of x, and for substitute in the equation y, and then you'll get a coordinate y, and this is your coordinates for the stationary point. Okay, always after this question we always have a question of to determine the nature of the stationary point. So we know that we have to find d square y over dx square, double derivative y double prime, and after finding y double prime we will be, if we'll get a positive number then it is a minimum, and if we get a negative numbers, and that means that we have a maximum. The nature of the stationary point is maximum. Okay, and the curve is going to be like this and this. Okay, so this is maximum and this is minimum. Okay, so that's it. Now let's move on to the next question, last question most probably. Okay, so last question of our paper, question 11. This question says that the diagram shows the curve. This is your curve. Okay, and this is your equation for the curve, and the points A and B lie on the curve. This is your point A, this is your point B, and you have to find the equation of the line. We know for the equation of line we just need two things, one point and one slope. So for the slope it is going to be y2 minus y1 over x2 minus x1. So this is what we have applied over here. y2 is minus 1 minus 2 and x2 is 2 minus 5. So this is going to give you 1. Okay, and the point we can use is minus 1 and 2. No, sorry, the point is 5 2 or 2 minus 1, so we are using here 5 2 point A, and we'll find this equation of our line. Now let's do the second part. Part B says that find the volume of revolution when the region between the curve and the line is rotated through 360 degree about the y-axis. Okay, whenever we have this kind of question, we know we have a few steps. About y-axis, that means we have to make x subject. Then, so we are doing this for the both equation of the line and equation of the curve. Okay, so first doing this for the equation of the curve, and this is for the line. Make x subject, so we are making this one and this one. Then we are doing squaring both sides. So squaring both sides, we get this and this. Now after squaring both sides, we will integrate the right hand side. So integrate right hand side, and what will be the limits? See, your curve the shaded region, see your shaded region is between that, this is a minus 1 point y coordinate, and this is 2. Okay, so your curve is shaded between these 2 points, so that you are going to apply the same limits for both, because both are starting and ending at the same point. Okay, first thing is this. The second important thing is that whenever we have to find the volume of like this, so we always do it like, wait, volume is equals to pi times right curve minus left one. Okay, so this will give you, first you will integrate the both sides, apply the limits, and then we'll apply this volume formula. Okay, so integrating these two, this will give you, obviously first open this square for both sides, this side and this side, and then we'll integrate it. simply integration is easy now. So just n plus 1 over n plus 1 on this one, then y, and okay, so this integration of 1 will give you y, and the y square will give us y cubed by 3, n plus 1 over n plus 1. 2 is constant, so it will come as it is. Then doing the integration of this side the same way, y square is going to become y cubed over 3 because n plus 1 over n plus 1, and then 9y and 6y square over 2. Now solving this, putting the values of the limits. First you will put the 2 in this and then minus 1. So show them by putting the limits clearly, and then minus 1 in both your integration. Arrange this all, solve them, and we get these two values, 15.6 and 39. Now I told you in the start that volume of this kind will give you pi times right curve minus left curve. So pi times integration of your line and the curve. So integration of your line was 39 and this was 15.6. So subtract and multiply with pi, you will get your required volume, this one. That's it. This is your whole working and your paper is ended. Thank you. Allah Hafiz.